This section examines the principles of the clutch. A clutch connects and disconnects one rotating mechanical component from another. An automobile clutch transmits torque from the engine to the transmission, and the driver uses a release mechanism to control the flow of the torque between them. Most light vehicles use a single-plate, friction-type disc, with two friction facings attached to a central hub, splined to accept the transmission input shaft. The friction facings are clamped between the flat surface of the engine flywheel and a spring-loaded pressure plate bolted to its outer edge. The input shaft passes through the center of the pressure plate to engage the splines of the friction disc hub. With engine rotation, the flywheel and clutch assembly rotate as one unit. Engine torque is transferred from the flywheel through the friction facings to the splined hub and into the transmission. Moving the clutch pedal operates the release mechanism to control the flow of torque between the two units. Depressing the pedal retracts the pressure plate against the force of its springs and frees the friction disc from its clamping action. Releasing the pedal reapplies the clamping force and reconnects the two units. When placing the transmission into gear, the transmission input shaft must be disconnected from the engine. When moving the vehicle from rest, slowly releasing the pedal gives a gradual engagement of the drive as the friction facings slip and allow torque to be applied progressively until both units are rigidly connected. When selecting an alternate ratio, that is, changing gears when the vehicle is in motion, the transmission of engine torque must again be interrupted for this to occur. And when bringing the vehicle to a halt, the transmission must be disengaged to leave the engine running at its idling speed. The amount of torque a clutch can transmit depends on the coefficient of friction between the friction facings and their mating surfaces, the mean radius of the facings, the number of facings in contact, and the total spring force. Increasing the diameter of a clutch increases its torque capacity, as does increasing the spring force. Two or more clutch plates can be used to form a multiplate clutch, increasing the number of facings and torque capacity. They are useful where a reduction in diameter is advantageous or where increasing the spring strength is undesirable.